Hey guys, this is Dr. Calkins. We're looking at week 7, chapter 17 homework. Granted, we did this before, the week before spring break, and then we got an extra week for spring break. So I'm going to go through this as quick as I can. But because I had so many question submissions, I think this is going to be enough preparation for the exam that I don't have to do additional lectures at this point. So let's just get to it. Number 2 has most unsaturated. Unsaturated just means look for double or triple bonds. And notice this one here, that one's saturated. So definitely not it. Here we have 1, 2, 3, 4, 5 doubles. Here we have 1 triple, and then here we have 1 double. So every time you have a double bond, you're going to lose 2 hydrogens. Triple bond's kind of like having 2 double bonds, so you're going to lose 4 hydrogens there. But here, losing 2, losing 4, losing 6, losing 8, losing 10, that's 10 hydrogens lost. Definitely the most unsaturated is the arenes. Number 5. Number 5 says lemon juice, citric acid. There's our clue. Citric acid for us is a acid-base reaction of, in this case, carboxylic acid. And then we already said that the fishy smell comes from amines. And amines are bases. So definitely an acid-base reaction. Number 11 talks about numbering. So in order to be hexene, we need 6. So 1, 2, 3, 4, 5, 6. If we have a 3-hexene, that would be 1, 2, 3 hexene on that 3rd carbon. It would also be 3 from the other way. So it doesn't matter if you go to the right or to the left. It's going to be a 3 either way. So this would be correct. So it's fine. They want to know who is incorrect, so we need to keep going. 2-hexene. Same idea, 1, 2, 3, 4, 5, 6. 2-hexene would be on that 2nd carbon. So there's the 1, 2 that they're after. An incorrect name for this would be numbering from the wrong side, 1, 2, 3, 4. That's this one, and the answer. So 2 and 4 are the same thing. These would be the same compound. This would just be named from the wrong side. 1-hexene is just fine. 1-hexene would be 1, 2, 3, 4, 5, 6. It would be here. There's the 1 that we would use because it's shorter and faster. 1, 2, 3, 4, 5 would be the bad number to use. Always go from the short side. Number 18. Here we talk about carbon. Saw this early in the lecture. Carbon is the only atom that can bond to itself a bunch of times over. Things like diamond and graphite are great examples. This is the definition of catenation. And that's going to be true. Diamond we learned in exam 1, in chapter 1. Diamond is the prettiest form for carbon. No hydrogens. Hydrocarbons are very weak. Diamond is very strong. We'll see that in some upcoming chapters. Diamond is going to be what we see as a network solid in our other chapter. So definitely looking at false there. Let's get down here. We've got a bunch of submissions, so let's hop through some of these. Isomers are tough. That's why gasoline's so expensive. It's a mixture of isomers, and the more isomers they remove, the more expensive it's going to be. So when looking at isomers, draw the longest first, which is 1, 2, 3, 4. That is the butane version of C4H10. We can also go 3 with a branch in the middle. 3 with a branch in the middle would be a 1, 2, 3, so that's a propane. Prop has 3 carbons, ane has all single bonds. And this has a group here, so it would be 2-methyl. 2 is the location, so numbers are always locations. And again, methyl is a 1-carbon branch, and this one only has 1 carbon. So it turns out there's only 2 isomers, not 3. So false there. 25. 25 says the IUPAC name for C4H8 C4H8 is butane. Butane says all single bonds. If we have C4H8, that's going to be a formula of CnH2n. We said if you have double, 4 and 8, that's double, that would be a double bond. So this would be butene. So false there. Turns out butane would have a formula of double plus 2. That would be C4H10. This would be an example of butane, as we see here. 26. This one would have been similar to that quiz that we never took. ROR. This is what happens when you have a R on ether side. And that's an ether. So that was our cute way to remember that one. Sounds good and true. Here we have formulas. Formulas are painful because we need to keep track of the number of hydrogens. So as we look at aldehydes and ketones, alcohols and ethers, it's important to know that these have oxygen. And notice, so far so good. The difficulty with an aldehyde, which is an R carbonyl H, or a ketone, which is R carbonyl R, is they have double bonds. And if they have double bonds, that's going to be 2N for the hydrogen. Just like it was up here for the 4 and the 8. So the fact that we have here a 5 and a 10 tells us this is true. This fits the CnH2nO formula we'd expect for an aldehyde or a ketone with a double bond. This double bond just doesn't happen to be between two carbons. It happens to be between carbon and oxygen and the carbonyl. Down here on 28, we're looking for alcohols and ethers, so it's going to be very similar, but we're going to expect CnH2n plus 2 because those are saturated in our Intro Chem organic class. Still have an oxygen. Double of 2 is 4, plus 2 is 6, so this is a perfect match as well. Alcohols are ROH. Ethers are, like above, ROR. So in both situations, these are terminal groups, these are internal groups. That's why they're isomers. And then lastly, with 29, we see the double, which is great. Double means double bond. In this case, for a carbonyl, carboxylic acids do have a carbonyl. They're a carbonyl OH kind of group. The problem is they have 2 oxygens and we only have 1. So false, this would be yet again another aldehyde or ketone with only 1 oxygen. 3. 1-propanol is the name for rubbing alcohol. Rubbing alcohol is called isopropyl alcohol. Hopefully using a lot of that in these trying times. We have 1-propanol. Isopropanol would be 2-propanol. It's the middle of the propane chain. So 30, in this case, like before, false. We have that alcohol in the wrong position. This matching section, a couple were kind of hit or miss, so I'm just going to show you how to do one, and then you can deal with the rest. And you already have this homework, but this is for students that submitted some questions. In this situation here, we're looking for an alkane. We just need to remember that alkanes are CnH2n plus 2. Hept is 7. So if you take 7 into that formula, you're going to double it. Double it would be 2n plus 2. So here we have 14 plus 2. We're looking for 16 for heptane. Down here for an alkene, double bonds, they have double number of hydrogens. So ethene, eth is, if you think of our acronym, my evil parrot bites puppies. So E is for 2. And if you take 2 times 2, you get 4. So just double those once you find the prefix and the number that represents. Again, the easiest way to remember is my evil parrot bites puppies, hexes, hamsters, only near Deloge. Those are those cues that we gave you in class a while back. Propyne, so triple bond. Going to continue to lose hydrogens, so now we're down to 2n minus 2 for hydrogens. We have prop, my evil parrot, so there's 3. So 3 carbons, we're going to expect double that, 6 minus 2, which is 4. So straight across. More formulas, students hate these. But again, it's all about a pattern. Recognize the number of hydrogens, recognize oxygens, nitrogens, halogens. So I'm going to pick this apart as you should do in the exam. Find a halogen, find a halo. Those should be some of the easiest. Find a nitrogen. Nitrogens have choices of amines or amides. But amides, because that letter D, have a double bond to an oxygen, so they need an N and an O, so this is just an amine. They get only one letter difference, so you got to be careful. Amide's going to have an oxygen and a nitrogen. C5H10, this is double. C5H12, that's double plus 2. C5H10, that's double. So the ones that have double bonds are going to be with one oxygen, aldehydes or ketones. Notice both choices aren't given because you wouldn't know the difference without the picture. 2 oxygens like we saw earlier, acids and esters. Again, ketones and aldehydes would fit that formula. And then if you're double plus 2, you're going to be the alcohols, but it could also be an ether that we learned in class. .48, what's the term for saturated? Saturated is an ane, so alkane. Arenes have the a ring-like structure, so not those. Alkenes are double, alkynes are triple. So who has a double bond? That's the ene. Arenes do, but keep in mind that's a hexagon with 3 double bonds, so it doesn't count. And then we have here triple bond being a Y in the ending, not the double, not the single, not the fancy ring system. All right, 58. 58 has 3 carbons in a row. 3 carbons is prop. So definitely get rid of ethyl, that's 2 carbons. Methyl, that's 1 carbon. We have 2 choices, propyl and, so isopropyl and propyl. Both have 3 carbons, but propyl is what we want here, because if you're in the middle of 3, like this one, here's the CH3, here's the CH3, so that's twice, and then the CH. This is the middle of propyl, and that's where we get that isopropyl idea. And that's where you'll see that rubbing alcohol from that true and false question earlier. Down a little bit lower, one group, 1 carbon is methane. It's attached to something bigger. We would call it methyl. Again, ethyl, 2 carbons. Isopropyl is the middle of 3. Attached to something bigger. Propyl would just be 3 in a row. Attached to something bigger. Ethyl, 1, 2. Attached to something bigger. Naming's important. So when we do these, we need to count carbons. So we have 1, 2, 3, 4, 5 across. We do have 7 carbons, but they're not in a row. So get rid of those heptanes because they have 7 in a row. We have 5 in a row. 5 in a row is going to be pentane, so now we're down to 2 choices. From the right side, looking across 1, 2, 3, and a 4. From the right side over, we have a 2 and a 3. They're both the same size, they're both methyls, so we say dimethyl, and 2, 3 is perfect on that. So as you look at 63, think the same idea. We think the same idea here, count across 1, 2, 3, 4, 5, 6, 7, 8 is octane, 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 octane. So notice in the homework like this, they're giving you a lot of answers. They're telling you how many carbons a lot of these groups are without any effort whatsoever because that's the only choice they're giving you. So use those clues to help you, definitely. So we definitely know it's octane. Isooctane, we don't see that ever in our class. The only thing we see is isopropyl, so you can get rid of those pretty quickly. From the right side, we have 1, 2, 3 is a branch, 4, nothing, 5 is a branch. From the right side to the left, we have 1, 2, 3, 4, and 5 and 6. 3 and 5 is better. 3 and 5 is shorter. So 3 and 5 only shows up twice, so we know 4 and 6 was the wrong direction. Now it's a matter of which is which. So 1, 2, 3 is one carbon, that's a methyl at 3. Check. And here we have at 5, 2 carbons, that's an ethyl. Again, think my evil paired bites, that's MEPB. Ethyl is only first because of alphabetical order. Very similar down here. We have 1, 2, 3, 4, 5, 6, 7, 8 octane, and notice oct. It's got a double bond. So ene. They're trying to give you answers to other questions. So really all they care about here is what's the better numbering system from the left moving right, 1, 2, 3, 4, 5, or from the right side, 1, 2, 3, 3 is better. And 3 is the answer. Always pick that shorter direction. Doesn't matter which one you choose, it just has to be shorter. It's very random on which one it's going to be. They purposely switch them to keep you honest. 70 we saw before a long time ago when we did those dot structures. It was our first example of a triple bond. Acetylene is the answer. It's what we use with oxygen to melt through steel pipes, exhaust pipes, and so forth. Ethylene is 2 carbons, but it's a double bond, hence the ene. Ethene is the exact same name, just the IUPAC name versus the common name. Ethyne is correct, but ethyne is the IUPAC name. The International Union of Pure and Applied Chemistry came up with those rules. Acetylene was the name that it had first, hence the common name, not the IUPAC name. But ethyne, acetylene, same thing. Lots of questions here, so let's keep going. Carbonyl groups. Aldehydes, check, that's an R carbonyl H. Carboxylic acids, a R carbonyl OH. Ketone is an R carbonyl R. Ester is an R carbonyl OR. So all the above. The only one missing of that 5 actually is the answer down here. An alcohol is an ROH. An organic halide is an RX, where X is some halogen, fluorine, chlorine, bromine, or iodine. Phenol is that arene system with an OH. The amide, which is the answer, is an R carbonyl NH2 group. General formula for an organic halide is all we need to see. Looking for that X for the halogen. Looking for an alcohol. Alcohols are an ROH. We said look for the OH in the name. 78, we say looks like a car key. So car key is a ketone. So those are those clues that we gave you in class that you probably forgot. But if you remember those clues, it's a little easier to remember than just flashcards or anything else. General formula is here again. So we saw some of those earlier, but let's go through them again. So this molecule is an ester. But remember, ester is maybe like grandma, and grandma has a key. The reason we have to worry about that is because if we were an ether, an ROR, it sounds very similar, it's spelled very similar in a sense. There's no key to an ether. It does have an R group on ether side, just like an ester. But grandma has a car key. Or you can even put in a cute little emoji. There's a little smiley face. And then here's grandma's little walker going to the store, who knows, but maybe that helps. Next we have nitrogen. So amines and amides, those are our choices, nothing else. But this one does have an N and an O, and more importantly, it has a double bond. And double bonds, we said look for the letter D, amide. Amines would lack that C double bond. For those old enough, you probably want some of this right now. So this is an ROH. That's an alcohol. The size of R doesn't matter. In particular, because this is 2, this would have been ethanol, which is the alcohol in drinking, and so forth. Next we have another formula. So here we have carbonyl H. Look for an H. We said aldehydes have H's. just like a ketone, but ketones would have groups on both sides. They wouldn't be terminal like an aldehyde alcohol kind of group. So look for clues on this one. If you didn't know what 3 carbons is, you got it for free because all these are propane and all these are 3 carbons. So if you didn't know what propane was on the exam, you could look for a question like this and that would give it away. It does have 2 chlorines, check and check. So we have a chlorine on the first and the third carbon. So first and the third carbon. Even if we numbered from this side, it's still first and third, and it's still 1 and 3. So those are ones that are trying to give you 3 points if you know what to look for. We saw isopropyl before, that's middle of 3 with an I. This would be an ethyl because it only has 2 carbons. This is propyl and it is in the middle, so check, that's what we want. This would be 3 in a row, and then iodine, that's normal propyl iodide or 1 propyl iodine, and then again this one is methyl. So get rid of those that aren't even the right length for sure. And then remember, iso is middle. 2-propanol is the answer to a true and false question. Made it false because 2-propanol is the middle of propane, and then that's with an OH because here would be your ROH kind of group. So look for the one that has 3 but 1 in the middle. 1, 2, 3, check. This one is the same as basically this one with iodine. It's on the end, so it's a 1-propanol. Here, this one's not even the right one. This is ethanol. It's not got enough carbons. These two, DNA, those are the same. It's 1 carbon here or 1 carbon there. It's still 1-propanol either way. These 2 questions, very important because you're in week 9, you're going to see them again. Most soluble in water means most polar. Like water. Water is HOH. Most people say H2O. But the reason I write it like this is other groups that are going to like water are going to be ROH or R-carbonyl OH or even an RNH2 or an R-carbonyl NH2. A lot of these groups we see in our biochemistry chapter coming up. But if you're like water, because you have those very polar bonds, all of these are capable of hydrogen bonding, which is going to answer the next question. So who's most polar? Those are the ones that are going to have an H, so we have 2 choices in this case. The issue that we have though is, do you think water likes 6 carbons that are hydrocarbons with a little bitty OH at the end, or does it like 3 carbons and an OH much, much smaller like water? And definitely it's going to like smaller. This is way too big and way too non-polar for water to interact. If you look at the notes, you'll see that for a lot of these kind of benzene kind of structures, they're big, non-polar. So even though they have an OH, they're kind of getting overridden by this gigantic structure behind them that's non-polar. 90 talks about hydrogen bonding. So look for those OHs or NHs. Here we see an NH, here we see an OH, NH, OH, so all the above. Turns out when you see all the above on this chapter and the next chapter, it's usually the answer. Not always, but if you're going to guess, I would go with that one because it's been fairly safe for us. Almost done, home stretch, 91. Here it says a lot of stuff, but it says lowest boiling point. So this is a perfect question again for week 9. Intermolecular forces determine boiling points. You see that in those other lectures coming up. OHs have hydrogen bonding. Super strong OHs have hydrogen bonding. So these are going to have really high boiling points because they're super polar. We'll see that later. These 2 here, those are aldehydes and ketones. Difference being on the edge or the middle of that C double bond O. So those are just polar. So those are going to have, mediocre boiling points. But definitely the winner here is the hydrocarbon butane. Butane is nonpolar. And if you're nonpolar, you're weak. And you're going to be easy to break apart, easy to boil. 93 says how many alcohols with this formula. So 2 carbons And you can put an OH on this side or that side. It's going to be the same thing. It's going to be ethanol. If you want an ether, ethers are different because, again, this is an ROH alcohol, so we had to put that R group on the right or left side. But with an ether, we have an ROR. It's got a group on ether side. So in this situation, we're going to put one carbon on each side. We would call that dimethyl ether. So only two. And the answer for a lot of these is 2, just like the one above it. These next ones go very fast. We don't even have to read this sentence. We just need to find chloro. And chloro is a halide, so organic halide. 95, if you're a vitamin B, ends in MINE, so find the one that ends in MINE and you're golden. A lot of those questions, just look for the clue. Just like in this one, look for the clue. They all end in OL, so find one that ends in an OL. Alcohols, phenols have OL endings to their names. All right, 2 left, and then we're done with this one. So here, cinnamon is also called cinnamaldehyde, so that gives away the answer. Because here's your aldehyde. Aldehydes have an H in their name and an H in their formula, so bingo. For practice though, again, this is the aldehyde of cinnamaldehyde. We have here a double bond that's called an alkene. And this ring is just like one that has alternate double bonds. They're just cheating. We would call that a ring, or better yet, a ring. We go down. Number 100, you see a lot of these practice things, drug molecules and stuff, and supplementals 9 and 10, as well as the end of experiment 10 in the lab book. So here we see those arenes. Those double bonds, sometimes written as a circle just because they alternate round and round and round. It's called resonance, but that's a topic for a different course, at least in this context. Here we have an arene OH. That's our AROH called a phenol. Here we have 4 iodides. Those are all organic halides. So there's that one. Here we have a group on ether side. There's that one. Here we have a nitrogen, but no double bond O here. This is the one that would need a double bond and doesn't have it, so we look for the letter N. There's the amine. There's a double bond on this one. That's an OH. Looks like you cough. Carboxylic acid's like vinegar. Might want to make you cough, and that COOH looks like the word cough in a weird sense. So all the above, go figure. So probably a little disappointing for me to go through that homework in 20 or so minutes, 30 minutes. So hopefully that helped. Definitely great to study.